Hi everyone, welcome to Machine Learning using Python online project based course with Skyfi Labs. First of all, import necessary Python libraries for the Boston housing problem. Import NumPy as NP, import Pandas as PD, import and so on. Unnecessary Python libraries must be imported. First of all, it is a best learning process, so that I'm saying. Otherwise, you can import at which time it required. The steps involved in the solving a problem with the machine learning techniques. Data preprocessing, define error. The last step is split the data into two parts, training data and testing data. Train the model. This step involves learning the target function from the given training data. Choose the appropriate machine learning algorithm for the problem. Train it on the data. Just the model with the testing data predict. The fourth step is finished. Next we are going to this step prediction. Obtain the predicted values for the given input and visualize the results. Let's move on. Now we are going to step 1, data preprocessing. Load the dataset. The main motto is to predict the prices of the Boston dataset. For that, the first step is data preprocessing. We are loading the dataset of the Boston dataset. Actually, this one. Okay. After loading it, uh, we are describing the dataset like this. We have in the dataset number of instances 506, number of attributes 13, the attribute information in order. These are all the attributes which is in the dataset. Missing attributes nothing. There is no missing attributes. Here we are creating a data frame using pandas, and we are displaying the futures data frame of the Boston data with columns. This is the output of the above code. We can print column wise as this features of age, so that the only the age here, the age column is being displayed here, because the after the features we have chosen only one attribute, i.e. age. Name of the attribute is age, length is 506, 506. The data type is float 64. Next we are taking target target data frame, and the target data frame is displayed here. In the target column we have 506 rows and 14 columns. Now we are describe we are going to describe the data frame with the data frame with the describe method. Count number of rows, mean of the column, std standard deviation of the column, min minimum value of the in the column, maximum value in the column, percentage 25, 50, 75 percent. A percentage or a percentage is a measure using statistics indicating the value before below which a given percentage of observations in a group of observation falls. Here we are going to describe the dataset in an as mentioned count mean. Here as mentioned count, we are just going to describe count mean standard of the dataset. Now we are going to next level. I visualize correlation of the attribute. We are using core method to visualize the attribute with target using the variable name CORR. Actually we are using here PLT. PLT means here already at the first stage we have PLT as plot matplotlib. Matplotlib is to visualize the data. Matplotlib is used to visualize the data. So we are here importing matplotlib and we are actually doing this. Here correlation with the target variable and in the y-axis attributes. The attributes are visualized like this. Next we are moving to we observe from the bar graph generated above. Normalize the data. Normalize the data with min scalar. X and y values we are taking like this, and before normalization it is like this. After normalization the values are, the normalization means putting the values into in 0 to 1, in between 0 to 1. Here before normalization the values are above 0 to 1, and here the values are in 0 to 1. Step 2, define error. Here mean square error we can give like this. And next we are plotting the error. The error value is stored in the error underscore value. We are using the power function using numpy np as a numpy. The mean square value function, the final answer, the final output is this. The three functions that constitute the model are error, update, gradient descent. The step 3, split the data. We already the contents are given over there at the top of the session. Let's move to step 3, split the data. Splitting the data into fixed sets. We are using xtrain, ytrain, ytest, xtest, and we are using split function to split the data. After that, it is a function to know the error, i.e. defining the error. Here error, this error is this error function, and the object function is this. After defining the error and also the update function, we are going to gradient descent function. This is how to define gradient descent function. That here, that percentage time is a magic function, as is told in videos of the Skyfi Labs while I learning this machine learning using Python. They said this is a magic function. Time percentage time is a magic function, so that the output will be like this, because how many iterations, while we are making iterations to how many iterations we are making 1000 iterations, so the wait time all time is 432 ms. Next we are going to visualization of labeling process. Here we are assigning mc and other values. Mc value with a gradient function, we already defined that. Using this we are storing the method gradient descent method into variable mc and error values and mc values. The value of m is this output. Next we are going to plotting the regression line upon the training dataset. We are using plt because we already imported the matlab mat or sorry sorry next, the output of the is here. Here we can see the model is in the red line, and some most of the points are on the model. Okay, next we are considering mc values and equal to mc values. We are using slicing operation here. Sorry, here it is the slicing operation. The values we are using here, and we are defining init function and also an update frame. Coming here, the animation is done with the func animation method. We already imported that animation, and here I use in lecture video, they use anime to HTML5 video, but in my lab it not working, so that I go for a JS HTML function. I mean, sorry, JS HTML method. Now we can see the animation by clicking here. Here, this. It's alright. Moving. The animation is going. I think so. Yeah. It is clear. After the animation, let's stop this. Yeah. Going to next step. Not next step. Going to visualization. The learning process. is this. We are using again matplotlib. We already imported this. It has plt, and output is this plotting error values. We are arranging like this, and here in x-axis the error, in y-axis the iterations. I have taken up to iterations 1000, so that the graph is like this. If we take up to 100 or maybe 200, it may be showing like this. Next we are going to final step, prediction. Predicted, we are testing x test, mean square error, predicted values, mean square error, y test, predicted values, and the data frame is here, x is here, target, predicted. We are using the head method to the to display output only some rows. Finally, we came to an end. Normalization. Here the predicted prices are these. These are the predicted values, prices. Thank you, Skyfi Labs. Thank you for giving this opportunity to complete my assignment. Thank you, everyone. Please subscribe.